red gack has been found to have the highest carotenoid levels of any known fruit or vegetable and is particularly high in two important carotenoids, lycopene and beta-carotene. There is an abundance of research into the effects of the dietary use of gack and its associated health benefits, but research into the skin application of gack products is very limited. There are a number of gack skin products on the market, but research into their effectiveness has not been conducted. These gack products use powders, oils or gack essence, which research has shown can reduce the levels of carotenoids in the product. What we aim to do is to create a product using the fresh gack aril and mesocarp with the intention of preserving the carotenoids in the product. The largest challenge with this process is that the minimally processed gack is susceptible to microbial spoilage, and so our experimental design will address these challenges by employing a heat treatment phase and a preservative phase to ascertain the best combination to reduce spoilage and improve shelf life.
We will create a potato dextrose agar with 200 grams of diced and peeled potatoes and put them in 1 litre of distilled water for 30 minutes. We will then filter through this mixture and keep the liquid. We'll add 20 grams of agar, 20 grams of dextrose to the solution and boil until that's dissolved. We'll then autoclave that mixture for 15 minutes to 121 degrees and then pour that into 30 sterilised plates and set overnight. To the red gack, aril, flesh and pulp, we'll blend both of those and then 5 samples of 10 grams and heat treat each one at 70, one at 90, 110, 130, then one with no heat treatment to act as control. After drying out these samples, we will add 0.1 gram to an Eppendorf with 1 milliliter of distilled water and mix together. We will then spread that out onto the potato dextrose plates and leave at ambient room temperature for 2 weeks to assess every 2 days to check if there's mould or bacteria growth on any of the plates.
At the end of 2 weeks, we commence the second stage of our experiment. We select the best temperature to use to continue. We are looking for no growth and consistent texture, no mould or bacteria in any of the plates. If there are 2 sets of plates, such as 70 and 90 degrees, both that are clear of any growth, we will choose the lower temperature. With our selected temperature, we will dry out the gack samples and plate onto potato dextrose media with the chosen cosmetic preservative. To 5 petri dishes, we will add tea tree oil. To another 5, we will add mint oil, Vietnam native oil to another 5, and leave 5 petri dishes to act as control without any preservative. Then we will leave the petri dishes at ambient room temperature for 2 weeks, checking every 2 days for growth. At the end of 2 weeks, we will select the best preservative to use in our cosmetic formulation.
For our experiment, we have divided it into 9 weeks. For week 1 and 2, we are heat treating the samples of gack arrows. From there, we will monitor the samples and to observe the growth of microorganisms. For week 3 and 4, we will observe the best heat treated gack arrows that has the least growth, and from there we would proceed to mix the sample with preservatives. For week 5, we'll find the most optimum sterilized sample of gack arrows and to formulate a cosmetic formulation with the gack arrows. From there, observation of the shelf life are monitored for a month. For week 9, final observations and assessment. We measure success by ensuring a product that shows no microbial growth when monitored for a month.